In this video, I will be outlining for you how to interpret quadratic word problems. When we are doing application problems, meaning we are applying quadratic functions to a real-world situation, we must first understand how to interpret the function. So I'm going to do, out of these 10 problems, 5 of them for you. We are going to be typing them in Desmos, so if you would, please pause and open up a Desmos app and drag it to the side like we did before. I will be opening up the Desmos calculator in full screen view, but I'll also be jotting some things down to help you understand. So if you want to either take a picture of what I do or write this down in your notebook, that would be great, but there is nothing to turn in today in terms of notes because really it's just about interpreting. So we're going to go ahead and take a look at number 1 of your assignment today called Quadratic Applications. And we'll take a look at this. So it says a company sells widgets. Widgets are just some generic name for some item that a company might sell. So a company sells something, and the amount of profit, Y, so I'm going to look over here. My Y is going to be represented by a profit made by the company is related to the selling price of each widget. So here, this is selling price. Our X is going to be represented by the selling price. So that's what goes on here on our X and our Y. So again, anything on the X-axis is represented by the selling price. And of course, the price that a business sets an object to be sold at is going to impact their profit, right? They don't want to sell it too cheap in that they don't make a profit, but they don't want to sell it so high that no one wants to buy it. So our profit function is going to be represented by, so our profit Y is going to be this equation, negative x squared plus 78x minus 512. So this function we are going to type into Desmos. And what I want you to understand about the graph so far is what we know based on functions in standard form. We know it's going to open down because our a value is negative, and we know that our y-intercept is negative 512. Okay, so what that means is if you think about the point y-intercept 0, negative 512, it means if they do not sell any widgets, they will be in the hole $512. Okay, $512 if they sell nothing. So you got to remember, a business has to incur some type of expense before they can make money. So negative 512 we know is our y-intercept, and I know the parabola is going to go up and come back down. Okay, if you notice on this xy coordinate, I'm only focusing on quadrant 1 and a little bit of quadrant 4, and that's because we cannot set a negative selling price, so nothing to the left of the origin is relevant. Only mainly the y-intercept here in quadrant 4 because it's negative, and here quadrant 1. So if they are asking us to find out at what price should widgets be sold to the nearest cent, so we want dollars and cents, for the company to make a max profit. So again, when they refer to the max here, they're referring to our vertex. So that is going to be our job, is to figure out what is our vertex. So now I'm going to open up Desmos, and I'm going to type in our function, negative x squared plus 78x minus 512. So remember, you can always pause me anytime. I'm going to open this up, and I am clearly, it comes down here, and I'm in this kind of negative 10 by 10 window. I need to kind of take my fingers and pinch them together to be able to see the parabola. And in fact, I'm probably going to have to drag it down here in order to see the vertex, and I can. So I'm just literally clicking and dragging this down so that I can see what is this vertex point. So I'm going to click on it, and there's our vertex. So I'm going to write this order pair down, 39 and 1009. And then go back to here. So I wrote it down here, 39, 1009. So it's very important to pay attention to the question. If they say find out right here, using this equation, find out what price the widgets should be sold, then remember, price is our x value. So we want the x from the vertex. So it says in nearest dollars and cents, so that would be 39.00. If for some reason you had to round, then you should do that. So 39.00, and that is correct. Okay, you do not have to put in the dollar sign, but you do need to put the cents. If it had, for some reason, 39.1234567, then of course we would round it to $39.12. So pay attention to that. So again, price is going to be your x value. So you do need to pay attention to what they define x and y as. So that's number 1. Number 2 is going to be a similar type problem, but it's going to ask for something different. So it says a company sells widgets. The amount of profit Y made by the company is related to the selling price X by the given equation. Using this equation, find out the maximum amount of profit the company can make to the nearest dollar. So different function this time, but we are looking for the Y value because that is the profit. So refer to your notes so you know which one is price and which one is profit, and make sure you're reading carefully. So I'm going to go open up my Desmos again. Did I just close it? I guess I did. So just as a review, once you click on Graphing Calculator, you can take this tab here and just drag it out of Chrome and it'll open to this side. So I'm going to type in the equation from my problem. Let me type it in right. Y equals negative. So what do we know? The A value is negative, so again it's going to open down. And we know that my y-intercept is my constant term, which tells us if we sell 0 widgets, they would be in the hole or in debt $1,279 for the cost of making that item. So let me go back here and type it in right. So y equals, let me make sure, negative 3x squared plus 197x minus 1279. So I'm good. I'm going to open this up and I'm looking again for my profit, which is y. So you can see I've got a piece of it, but we should understand that it's coming up and then going back down. So I want more of quadrant 1, and I want to take my 2 fingers together and pinch them closed on my keypad. And then I can click and drag down until I see the highest point, which is right here. That will give us our max profit. So now, what does this tell us? It tells us that we would need to have a price of $32.83. So I'm just going to write that down on just some scratch paper. $32.83 will give us a max profit of $1,955.08. Remember, if we're rounding to 2 numbers after the decimal, which is dollars and cents, that 3, because it's lower than 5, makes our 8 stay 8. If it was 5 or higher, this 8 would become a 9. So 1955.08 would be a price in dollars and cents. So I'm going to go, let me just minimize that and go back here to the nearest dollar. It says 1955.08. I wasn't typing anything. Thought I was. 1955.08. Submit. Oh, what does it have me doing? Oh, I didn't read. Oh, look at that. Didn't read to the nearest dollar. So I would need to round up if it was 50 cents or higher and down if it was below 50 cents. So I just didn't read carefully. Look at that. So we would need to go back and enter that in, right? So notice that you have 3 attempts. So if I go back in here and do it again and I read carefully to the nearest dollar, it would be $1,955 this time. There we go. All right, so next we're going to do, so now if I were you, I would pause the video to do 3 and 4, then come back to the video. All right, so hopefully you paused the video and did 3 and 4. We're now going to do numbers 5 and 6. Similar concept here, so I'm going to open back up to my notebook for 5 and 6 to understand this concept of height as a function of time. We should understand that as we read it, a rocket is launched from a tower. So remember, rockets would go up in the air and then come back down. the height of the rocket, y in feet. So y is the height of the rocket in feet. Okay? And x is seconds, time in seconds. So how long it stays up in the air, and this is how high it goes. So seconds would go on our x-axis, height on our y. And what do we know from the function? We know that because the a value is negative, it opens down. And we know that because our constant is positive 79, that we're already starting off, the rocket is already at 79 feet up in the air. And we would expect that that rocket goes up, then comes back down and hits the ground, okay? So they can ask us different questions. They could ask us, when does the rocket hit the ground? When does it reach the max height? What is the max height? So let's see what it asks us. Using the equation, find out the time at which the rocket will reach its max. So that means I want to know the x value at the max because x is time in seconds. So I'm going to go over here to Desmos again. I'm going to type in negative 16x squared plus 225x plus 79. And I'm going to come over here and hit this home button, which kind of takes it back to a default. So remember, I adjusted my window for the last function. So I'm just, again, pinching my fingers in. I can see both sides of the parabola. I want to drag it down so I can see the top. So how high is this rocket going? Pretty high. So we're just going to keep dragging. Starting to get skinnier, which means we're reaching that max point. We can zoom a little more if we wanted to. And I'm just going to click right here at the top and hover over it. And what do we see? We see that the max height, the max here, max point is 7.031 and 870.016. So you got to keep in mind again, what are they asking for? I wrote that order pair right here in my notes. So if they want to know when it reaches the max, that's the x value because x is time in seconds. If they want to know how high it goes, we would type in 870. But what are they asking? Find out the time to the nearest 100th of a second. So what place is that? Well, the first is tenths, hundredths, thousandths. So if I want tenths, hundredths of a second, that would be this number right here. And if this 1 was 5 or larger, the 3 would round up. So the nearest 100th, tenths, hundredths would be the second number after the decimal. So I'm going to type in 7.03 and submit my answer. And that is correct. All right. I'm also going to do the next one for you, which is 6. And then you'll notice here, see how it says height, time, max height, and then it says height, time, max height. So after I finish 6, your job will be to pause it and do 7 and 8. Then I'll come back and do 9, and you won't need to do 10. So number 6, similar concept. It says a rocket is launched from a tower. The height of the rocket, y in feet, same as before, is related to the time after launch, x in seconds, by the given equation. Using this equation, find the max height reached by the rocket to the nearest tenth of a foot. So this time, tenth of a foot. So remember what I said, tenths place, if this is tenths, hundredths, thousandths, tenths place means they want us to round it to one number after the decimal, okay? So if this were the right equation, it's a different equation this time, but we want to round to one number after the decimal. So I'm going to take this equation, open up Desmos. Did I close it again? I'm good for that. All right, I'm going to go ahead and type that in. Y equals negative 16x squared plus 261x plus 130. I'm going to look and just make sure I typed it in right. Looks good. Open this up, and I'm going to start pinching. I want this max point. So you could keep squeezing, but see how skinny it gets? We don't really want to do that. It helps to see the parabolic shape if we drag it a little better. If you get like if your screen gets solid whack, again, always go back to your default zoom. So I want to round this number, the y value, to the tenths place. So if my ordered pair, I'm going to write this ordered pair down, is 8.156 seconds. So a little after 8 seconds, it reaches its max height of 1,194 point. And because I have 391, this 9 is going to make the 3 round up to a 4. And that's what I type in, 1194.4. So if you're getting it wrong, you need to go back and check your rounding. Okay, I'm going to minimize it this time instead of close it. And just type in, again, without units, 1194.4. And I'm good. And of course, it'll give you explanation here, nearest tenth of a foot. Make sure it's rounded correctly. All right, and you should at this time join me after you have completed 7 and 8. So go ahead and pause the video and try those. All right, I'm assuming you paused the video and completed 7 and 8, because by the time I finish, you should be about done with this assignment. So let's click 9. This says I've got another rocket being launched, but this time it says a rocket is launched from a tower. The height of the rocket, y in feet, is related to the time after launch, x in seconds, by the given equation. Using this equation, find the time that the rocket will hit the ground. That's different than the other problems. To the nearest 100th of a second. So time it hits the ground, what would that represent? So back to my notebook. So gravity as a function of time. Again, they're telling us that x is in seconds and y is feet. Height in feet, rather. Height and the unit feet. All right, so what do we know? We know the parabola opens down because our a value is negative, and that the initial height of the rocket is here at 61 feet, and we would expect the rocket to go up and come back and hit the ground. So understand that the x-axis represents the ground, and y again is our height. So if our height is 0, I'm wanting to know this x-intercept this time. So this is our goal for these gravity as a function of time where it hits the ground problems, okay? And it says to the nearest 100th, so tenths, hundredths, that's going to be the second number after the decimal. So we're going to go to Desmos and type this in. All right, gonna graph that and open my window up. Clearly I've changed it and I don't see it, so I'm gonna hit this home button. So see how it takes me back. By the way, if you wanted to change the color, you could come over here and you can make it whatever color you like over here. You got all these options. You can make it dotted if you want, but leave it solid. So again, I'm going to pinch my fingers together. Oh, and this is, I know it's going to go up and hit the ground. This is the point that I want where it hits the ground, which is our x-axis. So I don't need to find the top. If I'm going to round to the hundredths, there's my time. So 10.972 seconds is what they give us. But they say, I think it said round to the hundredths, so that's tenths hundredths. So if I have 10.972, let me go back to my notebook here. If I have 10.972 and they are asking for the nearest 100th, again, that's tenths hundredths. So I'm going to look at 10.97, and if this 2 is 5 or larger, the 7 would round up to an 8. But because it's below 5, I'm going to keep it at 10.97 seconds. And that's all there is to it, guys. So take the time to go ahead now and complete 10, and you should be done with this assignment. Have a great day. Let us know if you have any questions.